Alrighty, for this one, we're going to talk about ionic nomenclature, and ionic nomenclature is kind of a sticky point. Uh, I mean, I love nomenclature, so this is one of my things. But um, in Gen Chem, naming ionic compounds is kind of a challenge. So I've kind of broken this down into a couple of things. Uh, we're going to start off with this one. We're going to think about binary compounds, and when we're thinking about this, and every ionic compound is named kind of the same way, so we just have to get some of the details down. You're always going to have a first name and a last name, just like most humans have a first name and a last name. The compounds have a first name and a last name. So the first name is always the cation name, and the second name is the anion name. Okay, so the positive thing first, and then the negative thing. So what we have to be able to do is figure out what are the names of these cations and anions, and then if we see them together, the name is just the two things together. Okay, so let's give this a shot. This is put out, I should define this because I have it written right here, by the IUPAC, the International Union of Pure and Applied Chemistry. And among other things, one of their big jobs is coming up with all the rules on how to name stuff. Okay. Uh, so we'll kind of mention them a lot on and off as we do things. Um, all right, let's take a stab at stuff. We're going to just go piece by piece. Uh, anions. Anions first because they're less complicated. Um, Remember that to make an anion, uh, we're going to take the atom and we're going to gain enough valence electrons to get a total of 8 valence electrons. Okay, which means we're going to end up with a charge of the A group number, excuse me, -8. Uh, and when we're naming these things, what we're going to do is we're going to take the root of the element name, and some of those are straightforward and some of those are not necessarily straightforward, but we'll figure it out. And we're going to change the ending to IDE. No matter what it is, we're going to put IDE on the ending. All right, let's look at some of these dudes. So for example, Br minus, that's bromine. So this is bromide. If we have Cl minus, that's chlorine. So this is chloride, right? This happens a lot. If we have O2 minus, this is oxide. I'm thinking what are some of the other ones? Sulfur becomes sulfide. Oh yeah, nitrogen is one. Nitride. Okay. Um, and so on and so on. You can kind of just make a name uh, for something and just swap IDE on the ending for it to work. So like hydrogen forms a negative ion sometimes, and so this is hydride. Or you have an element you don't know all the time, but you see it as as an ion. That's tellurium. So your big guess would be this is telluride. Okay, and so on and so on. So we can do that without too terribly much stress. Okay, the stressful part comes with the cations because as we've seen before, there's two different flavors, some that have no options for charge and some that do have options for charge. Um, we'll start off with the no options one because this is going to be, again, a little bit more straightforward. So this is almost all of the main group metals, and a few of the transition metals will have this no options, right? And when you have no options, it means you lose all of your valence electrons and that the charge is equal to your A or B group number. Okay, so uh, so for example, if you have a sodium's in group 1, it loses 1 and becomes Na plus. Okay, now the nice thing about these guys is the name is just the name of the element. Okay, so sodium is sodium, so this is, oops, sodium. Okay, Al3 plus, no options, that's aluminum. Right, whatever those are. Remember the ones that are transition metals that don't change, things like silver plus, zinc 2 plus, cadmium 2 plus. We don't see scandium and yttrium very often, but they are invariable charges. So this would be a silver ion. And sometimes you'll see this, I'm not sure if Alex will make you do it or not, but uh, the official names of these all have the word ion on the end. I drop it all the time just because we know what we're talking about. But if you're talking about zinc or something, you want to make sure, oops, you want to make sure that you tack it on there so you know we're talking about a zinc ion and not a zinc atom in the elemental form with no charge. Okay, so the no option ones are okay. These are transition metal ones that have no options, so we can remember to kind of put those in there somewhere. Okay. Now, if we're looking at cations with options, then we right. The reason these guys have options, this is most of the transition metals and a handful of main group metals, is that they can either lose some of the valence electrons or all of the valence electrons, or varying numbers of valence electrons. So they're losing varying numbers of electrons, so they end up with options for charge. Okay. There's two ways to do this. I'm going to show you the old way. Uh, the old system uses suffixes for relative charge. So that means a higher charge is ic, a lower charge is us. Okay, right charge here. I'm sorry if you can't read this. I'm trying. Okay. Um, the downside of this and why I don't ever test on this or anything is because the old system requires you to use the Latin name, if there is one. So, for example, if you have an iron 3 plus, iron is ferrum in Latin, and so this is ferric. Okay. Uh, iron 2 plus then is the lower charge, and so that's ferrous. And really the only good reason I talk about, okay, so I guess there's two reasons. The legitimate reason is that you might work in a lab someday where you see old bottles of stuff that's labeled this way. Um, and you kind of need to know along the lines of what that is. The other one is so that you get horrible chemistry jokes. And I used to draw this myself, but I found this picture and it's awesome. So what is this? This is a Ferris wheel. Okay. Cheesy, cheesy, cheesy. I know. All right. So let's get to the important one. The system we use now and what everybody uses now is called the stock system. And the stock system uses English names, and it uses a Roman numeral, and the Roman numeral is equal to the charge. This is the sticky point. Okay. Are we back? I think we're back. Hopefully, I'll have to make sure we have sound. Um, yeah. So the Roman numeral is the sticky point. The Roman numeral means the charge. Okay. So what that means is that if you're trying to name something or come up with a formula, you want to make sure you're thinking about it in terms of charge. Some people think of it as the number of atoms that are there, and that's just not right. Okay, so how do we do this? So we'll use our ferrous and ferric examples again. So there's ferric, there's ferrous. So we're going to use the English name. Both of these are iron. So this is iron 3 plus. So this is iron 3. This is a 2 plus. So this is iron 2. Really straightforward. We just have to know what the charge is, and since we're told what the charge is, it's okay. There are the handful of main group ones, mainly lead and tin, which could be 2 plus or 4 plus. So that's things like saying Pb 4 plus would be a lead 4. I don't want to do lead again. I'm going to run out of room. Tin 2 plus would be a tin 2. Okay, so the Roman numeral is just whatever the charge is. Okay. Uh, yeah, that's all I really need to say on that. So this actually works nice because the ick and the us system only thinks about having two options, but there are things like manganese and vanadium that have several options, and so it's best to what's the word I'm looking for? That you use the Roman numeral system, then you don't have to worry about changing the name or doing any of that kind of stuff. Okay. Now, once we have the names of ions down, right? Notice we've only focused on binary things. These are monatomic ions. Okay, we'll step it up later. Right, we can put together what the name is. Okay, cation name first, anion name second. All these little flowchart things that I find places. This is, I think, from an old book I have somewhere. Anyway, so we know it's going to be an ionic compound. Then we just have to figure out, okay, does it have options? Does it not have options? And it always ends with IDE for the anion, and then you may or may not need a Roman numeral. All right, let's take a stab at some of these. All right, so in the beginning, one of the best ways to do this is look at the formula, right? So what we're doing here is taking the formula and turning it into a name. So look at the formula, turn the formula into ions, and then you can name the two ions, and that's literally the name of the compound. So we can have, and this is Na plus, Br minus. Okay, so that's a sodium, and this is a bromide. Okay, none of this is capitalized unless you're the first word of a sentence, but I don't know how much people stress about that. We're not going to do a lot of writing. So there's a silver plus. We have an O2 minus. This is silver. O2 minus is oxide, right? Not too terrible. All right, I'd have to move this little, I lost my mouse. Shoot, okay. This is iron. Now see, iron has options. So let's do this the other way around. How we're gonna think through this. I really wanna move my little video square. There we go. Okay. Iron has options. So we don't know for sure at the moment if that's going to be a 2 plus or a 3 plus. So look at the sulfur. So remember, anions never change. So this is S2 minus. Because this is 2 minus and it's 1 to 1, this has to be Fe2 plus. Now that we know what the ions are, we can name them. This is iron 2, and that's a sulfide. Okay. No space between the name and the parentheses, but you want a space in between the two ions. Okay. Let's look at this guy here. We can do the same. I should have done something besides sulfide again. We need to do the same idea here. Or you can recognize, maybe you'll recognize aluminum doesn't have any options. And so aluminum should be a 3 plus. Sulfur should be a 2 minus. The other way to get this is you can do the switcheroo backwards. Remember we talked about the switcheroo when coming up with the formulas. This 2 becomes a 2 minus on the sulfur. This 3 becomes a 3 minus on the aluminum. 3 plus on the aluminum. And there we go. And now, since this doesn't have any options, we don't need a Roman numeral, so this is aluminum. And S2 minus is sulfide. Okay. And we have this next guy. We know what Cr is. Cr, let's see. Again, this guy, chromium, has options. Chlorine won't, so this is Cl minus. There's 3 chlorines here, so this chromium has to have a 3 plus. Since chromium has options, we can say this is chromium 3 chloride. Okay. Looks like we got one more. Don't have a good color for that one. We'll use this. Okay. So again, we have a 2 and a 3. Let's do the switcheroo again. So this 3 must go on the nitrogen. This 2 must go on the calcium. So this is a calcium 2 plus. That's like A. I made it worse. Okay. And the nitrogen has a 3, so that has to be 3 minus. Calcium has no options, so this is just calcium. And nitride. All right. Now, one of my rules of Gen Chem is if you do it forwards, you should be able to do it backwards. Okay. So here's some names. Let's come up with what the formula is. And this is just the reverse of what we just did. So if we start up here, lead 2 sulfide. In the beginning, eventually you should be able to do this in your head, but in the beginning, you can probably just write down what the ions are based on the name and then put a formula of those names. And we've done both of those things before. So lead 2 is a Pb2 plus. Sulfide is an S2 minus. So a lead 2 plus and an S2 minus is PbS. Okay. Okay. Strontium bromide. Strontium is Sr 2 plus. We know that because it's in group 2, so it has to be 2 plus. Bromide is in group 7, so that has to be -1. So then this means we're going to need 2 bromides to go with the strontium, and so we have SrBr2. Okay. And lastly, we have manganese 4 oxide. So let's look at this. We have manganese, Mn. 4 means that's a 4 plus. Oxide is a 2 minus. Okay. If we look at this and do the switcheroo, you're going to get close, but you're not going to be exactly right because you're going to get Mn2O4. Okay. Remember, your ionic formula has to be the lowest whole numbers possible. So instead of Mn2O4, we can reduce that down, and this is MnO2. Okay. If you need anything, let me know. We'll revisit nomenclature several more times. Uh, have a good one. Let me know if you need anything.